Am I audible? I think folks at the back are suggesting I'm not. Am I audible? Can you increase the volume for this? Hello? Am I audible? I think that's too loud. All right, folks, that was quite a wait for our session to get started. Of course, if we have members of parliament sitting here, I think our session takes some time, but great to see such a crowd. I haven't seen such a full house for our talk, even if I think we three have delivered around 50 talks in the last 1 year. This is the largest we are seeing in terms of the room capacity. I mean, we have seen 200 folks, but yeah, overcrowded, of course. So we are going to talk about AI in the cloud native era. Just a show of hands, how many folks are working with cloud, Kubernetes, or AI? Okay, all of you. I'm sure you're not just turned up for the talk without knowing what the talk is about. So we have an agenda. Usually, uh, I try to keep the agenda open to interpretation, not a specific agenda, but we are going to talk about ourselves. We are going to talk about the state of open source AI, how AI is today in the Kubernetes ecosystem. We are going to talk about building the infrastructures of today, and then we'll, of course, talk about tooling, strategy, the challenges that we are facing in the cloud native era, and how you can run AI on your platform. So the cake is basically the layers that we are going to cover. So we are going to cover layer by layer how to reach the right strategy, how you can build your platforms, or what's the right platform strategy today, moving towards the AI native world and a congregation between the cloud native and the AI ecosystem. Okay. Okay, I think they want us to have a group photo first before we start our talk, so we'll do that. Are you related to the organizing team somehow? Can you give me some space? Like you're literally on my feet. We have three speakers only. I am on speakers. Me, Prithvi, Bharat, and Satya. All right, folks, sorry for the delay. We can get started now. A lot of photo ops and all that stuff. I hope we can utilize some of the AI we are learning here to improve the food that's outside as well. But moving ahead, a quick introduction of us. My name is Prithvi Raj. I'm a senior community manager at Mirantis. I am also a CNCF ambassador. Folks who are aware of the CNCF or want to ask any questions, feel free to reach out. I work for KCD Bangalore as well, organizing KCD Bangalore. I traveled from Bangalore this morning and I'm straight at this venue. But yeah, I'll do a lot of stuff on the platform engineering side. So if you have any questions on platform engineering, feel free to ask me post the session. Quick introduction of Bharat and Satyam.
Hey everyone, good afternoon. So my name is Bharat. We're all from Mirantis, and I lead the open source program office team at Mirantis. For those of you who don't know what OSPO is primarily, a team which focuses on upstream technologies and, contributes back to the community, the tools and technologies that we end up using in enterprises. And as you might know, most of the tools and technologies, directly or indirectly, is dependent on open source stuff. So yeah, so that's what Mirantis focuses on. Like we're going to talk about the product in this session, but yeah, primarily that.
Hello, everyone. I am Satyam. I'm with the same team, OSPO at Mirantis. I'm a software engineer. So yeah, we contribute to a lot of open source technologies. I'm mainly towards the CNCF landscape, if you know about it. Kubernetes, that's where I specialize with vendor-neutral composable infrastructure, and our slides are related to that, so you'll see a picture of it.
So a little bit about Mirantis, because a lot of folks might not be aware, but Mirantis is one of the pioneers of private cloud environments. The journey started back in 1999 when I was born. But the company has been pretty robust, been doing a lot of things in the private cloud ecosystem, a lot of end users particularly who started using Docker and now moved on to Docker Enterprise, use Mirantis, people who used OpenStack and are aware of the OpenStack landscape that was again driven by Mirantis, and today again the Kubernetes and the platform engineering with the AI implementation is being driven by Mirantis. So you can see this has been the journey. The private cloud pioneers of around 2011, 2015, and then we moved on to open infrastructure, acquiring Docker Enterprise, the launch of Mirantis OpenStack Kubernetes and Mirantis Kubernetes Engine, and of course Lens, which is an interactive UI for utilizing Kubernetes. And then this has been the AI revolution where we are focusing more on Quadrant, which of course Bharat is going to talk about, and how the AI landscape is. So let me start from the basics. I know a lot of folks must be aware of a lot of things, but I'm going to start from where the idea of cloud initiated, or what was the idea behind cloud. What customers expected or what the end user expected was a simple interaction between a data center and a cloud environment. Usually it was a public cloud environment, how it started, but this is how the reality is of today. You see multi-cloud environments, and I mean, you see so many data centers. One organization is not even using one cloud provider. One organization might be using Azure and then AWS, and then have some edge environments, a private cloud, hybrid cloud in place. And then there are so many APIs under the hood interacting with each and every cloud, each and every service. And instead of being simple, cloud in itself has become so complicated for its users or companies. And what started as one cluster, one cloud, has become multiple clusters, thousands of clusters, 20 plus clusters is pretty simple for a particular team. There's no unified control, and platform engineering as something which is called so-called niche in today's ecosystem, even if I believe it has existed since the mainframe days, has become pretty complex. I mean, you can see there's Kubernetes as the, common control plane or the OS of the future under the hood, but you can still see so many APIs that are interacting with each other and making things complex. So the idea, as I said, is to make Kubernetes as the common control plane. And you can see, I believe calling Kubernetes as the OS of the future is not too optimistic. It's the reality. We are moving towards a generation, especially with how people are moving from virtual machines, VMs, and hyperscalers to utilizing containers and Kubernetes in their ecosystems. Kubernetes is going to be the common control plane and a powerful control plane, a powerful scheduler for all your infrastructures. With this, I'll talk a little bit about the cloud native survey that was, curated by the CNCF. And you see, today we have around 15.6 million cloud native developers who are utilizing some form of Kubernetes technology. And 52% of them are AI ML developers, which is more than a half, 7.1 million, of course. And as you can see, 36% of them have already utilized or are running AI workloads on Kubernetes in some form. They are utilizing some sort of agents with Kubernetes. Kubernetes are being run on GPUs, and then 18% of them are in the planning phase, where you can call them in the developmental phase, where they are utilizing multiple workflows to reach that production phase. But we are already noticing a big change in the last couple of years, especially with the LLMs growing, with how agents have come in. People are moving towards utilizing Kubernetes in their AI workloads. So with this, I'll allow Satyam to talk a little bit about the challenges that we are facing while building AI infrastructures, and then we'll move on to tooling and how platforms look like in today's world.
Thanks, thanks, Prithvi, for building the nice foundation. Um, okay, folks, so let's talk about AI. It's not. Okay, so we are already talking about AI. And when we talk about AI, the first thing that comes to your mind is somewhere on the, an interface, you're gonna prompt something and you see some results. But when you prompt something, it's just not models, it's the whole stack. So when you do a request to ChatGPT, it goes to some GPU in some data center. And that's where your infrastructure, the whole chain, the supply chain starts, okay? So there is GPUs. When you have GPUs, you have storage, networking, monitoring as well. So all of those are the aspects of, when you develop an AI application. And one can't reiterate on building intelligent application without defining, proper infrastructure. And now so much so that we are burning GPUs. I mean, literally combustion. And so the demand is going, again, higher and higher. So companies are looking to optimize their infrastructure, as well making it readily available to their development team. Okay, so yeah, we're going to talk about infrastructure. I'm going to start with Kubernetes. So Prithvi already built a base. And I saw a lot of folks here who already know about the Kubernetes, but I'm going to try and give a very simple explanation of Kubernetes and why this tool is so much popular around. So think about it. So you have an application and you are running it on a server. Server is basically a computer. And let's say you have 5 of those machines. And if you can make it possible to run that application, if one of the, the machines goes down, the seamless networking, storage, and everything all together interconnected, that's Kubernetes. So it's not just web application you can think about in terms of AI applications as well. Okay, so Kubernetes is a very resilient infrastructure for deploying any kind of application. You also get automation, scaling, and auto-healing out of the box. And if you know, Kubernetes is also the second largest open source project after the Linux. It has a self-governing body. So, not a singular company who is in control of what goes on. It's the maintainers. It's the open source maintainers who control the life cycle of the whole Kubernetes. Okay. So Kubernetes is a mature tool, and it has a very huge ecosystem. So what companies are doing, they can build on top of Kubernetes API. So let's say you have a business application where you want some specific tooling. Let's say you want some sort of KV cache optimization or something around training or some optimization. So the companies can build their own APIs around Kubernetes. They can open source it and reiterate quickly to develop their application. So to give you some examples, if you've heard about Kserve, LLMD, so any sort of AI ML pipeline in the whole ML ops pipeline, any sort of application you can think about, you should be able to find it. If not, you can always create your own open source application and get the community to get feedback and contribute there. So when AI wave took place, we know AI wave from ChatGPT 2022 or something. So Kubernetes was uniquely positioned to answer some of the infrastructure challenges that we see right now. And that's why we call it the present of intelligent operations, not the future. Okay, so yeah, I talked about why Kubernetes is ideal for the AI era. And Kubernetes, the tooling is GPU aware. You also get auto scaling for the infrastructure across clouds. But as the Kubernetes adoption matured, the complexity also exploded. So you have multi-cluster, multi-cloud. So you can also expect inconsistent APIs. You can think about clusters, the 5 machines that we just talked about in different regions. And let's say 100 of those, that's already a complexity. So we have fragmented tooling, which is a new challenge. And this is just infrastructure. I'm not yet coming to the AI thing. So this is infrastructure challenge. So let's say if you want to deploy 50 of those clusters, you'll be dealing with n number of YAMLs, which is what we don't want. We want one YAML, one turnkey YAML to deploy all infrastructure. Maybe it's GPU or without GPU. Yeah, so building on that. So these are the infrastructure challenges that we have right now. Starting with the multi-cloud complexity. So as an environment grows, visibility also gets worse. So as I told that if the infrastructure in different regions, you don't have control over it. You don't have a centralized view of each of your clusters. And tooling becomes fragmented. So even GitOps principles, so if you have heard about some of the GitOps tools in this ecosystem, they can't handle this stress. So cluster starts to drift across environments. Then second, we have also regulation and compliance. You would have heard about the recent drives, the sovereignty drives across Europe and all. So we have requirements around the data privacy, audit trails, and cybersecurity as well. But to do that, we want consistency and visibility across our environments. Yeah, and we have now regulation and compliance, if you see the other points. This adds to the whole new layer to the AI. Organizations want to onboard GPU faster and improve GPU utilization and support multi-tenancy, etc. But without automation, all of that becomes difficult and expensive. So the takeaway is simple. Modern infrastructure is harder. And without automation, we can't reiterate faster. OK, so we just talked about the infrastructure challenges. Now let's talk about the AI infrastructure challenges. And we can basically put them into 3 categories. The first is tech stack complexity. So it's not just Kubernetes, which comes around when you talk about the AI infrastructure. There are different toolings. And because there are so many toolings, we don't have standardization. OK, there are countless frameworks, platforms, etc. And everything has to integrate correctly. Everything has to scale. Everything has to stay updated. Next is operational efficiency. So even after, let's say, if you're a company, you're building your own tech stack, own infrastructure around the GPUs and AI. So even if you have the stack assembled, the real challenge begins with operating it. As we talk about utilization, provisioning speed, also the networking around it. So all of those matters. And lastly, the customer experience, or a user experience. We want fast onboarding. So the state of the current world, where if you want to request a GPU on any of the hyperscalers, it's going to take you 6 weeks. And if it's one of the high-end tech stacks, in some countries it's just not available as well. So we want fast onboarding, pre-configured environment, and reliable performance as well. So this is all that makes AI infrastructure a little complex and unpredictable as well. And lastly, one of the challenges I want to talk about technically is multi-tenancy. Because these devices are so high-tech and they are costly as well, so we don't want developers to have their own set of GPUs, which is going to cost like more than 20,000 for one high-end GPU. So for that stuff, we have multi-tenancy. So you can think about it. We have different algorithms, and with number of vendors, we have different sort of algorithms. For example, AMD, or you want to use NVIDIA, they will have different sort of slicing algorithms. If you had heard about time slicing or multi-instance GPU. Even with that, we have challenges. For example, fragmentation, noisy neighbor, because essentially we are sharing memory there. And we're going to all talk about all of this, how we can resolve this in the upcoming slides. OK, that's me, Prithvi.
Right, thank you so much, Satyam. Let me go back to the previous slide on multi-tenancy. So these are three examples because your node is never distributed in a single form, or we are in the hyperscaler world where we believe that resources can be in one form or one data center. That's not how it exists in terms of multi-tenancy in the AI ecosystem. You can see in one way there are tenants which are interacting with just VMs over the hypervisor, but you can see a tenant interacting directly with the hypervisor and the nodes as well. And that is where I feel, and then there's the tenant which is interacting with the operating system. That can be your Kubernetes or your Linux. And then there are people who are hosting their workloads or Windows or Mac as well. So multi-tenancy, as I said, there are different teams, there are different enterprises utilizing their workloads in different ways per team. And that is why it is complex and has so many options. And that is where I believe the AI way of doing platform engineering is ensuring that you're not just having your multi-cluster, multi-cloud orchestrations in place, but you're also ensuring that your GPUs that are hosting all your multi-tenant ecosystems are also having, say a multi-cluster or a multi-GPU orchestration in place. But before that, before we talk about platforms, we'll talk about the Kubernetes AI conformance. I believe a lot of you who are utilizing Kubernetes are aware of the Kubernetes conformance. But the idea behind the Kubernetes AI conformance was to ensure that you are able to make your AI workloads running on Kubernetes repeatable as well. Many of the tooling that's out there, even if you are, say, utilizing your GKE or your AKS, all the Kubernetes service providers are conformant in nature, which ensures that there's a sense of, it can't be it works on my cluster, but it doesn't work on yours. That's not how it's going to work in terms of, implementing Kubernetes in the AI ecosystem. And that's where I think a set of folks alongside the CNCF came together to ensure that your AI ML workloads are portable, even if you are hosting them on your GKE or your AKS or your private cloud environments. You are able to run it on your clusters, and then it's giving the ecosystem a clear baseline. So you can check out how you can make sure that your platforms are AI conformant or Kubernetes AI conformant. But these are the 6 factors driving it. Of course, the hardware accelerators, which pull up your GPU or pull up your hyper scalers, you need to ensure that they are, of course, conformant. Your operators, which are helping you interact with different systems. Scheduling, you need to ensure while you are scheduling one resource at a particular time, again, it's conformant. And the last 3 points, security, as I spoke about, or as Satyam spoke about, we are moving towards the DORA matrices in Europe. The CVs and the security audits have become pretty important. And then the observability side of things, I'm not sure how many of you folks are using OpenTelemetry or any other observability tools, but the way a Kubernetes-driven AI platform is seen is that you need to ensure that you are using the right tooling, which, has the right audit, is perhaps CNCF graduated because it goes through multiple audits, and then drives your platform conformance, of course. So these are the 3 pillars of open source AI today. We, of course, talk about agents, which is the last stage. But let's start from the beginning, which is training your models. And as you can see, PyTorch has around an 80% share of training on Hugging Face. But training your models is nothing but ensuring that you have the right data in place. You are able to develop your models with the right data sets, and then you move on to the inference side of things. Inferencing is nothing but ensuring that you are having the live data training on a model that is already trained. And that is where the idea of LLMD, VLLM, AI bricks comes into place. We'll take a look at the couple of projects, and then of course agents. That's the last step, where you have the agents in place. They're interacting with your systems. They are doing the activities or tasks you want them to do. It can be node selection, it can be identifying the memory, it can be interacting with an MCP server. So these are the 3 pillars of open source AI today that are majorly driving the AI journey towards your cloud native ecosystem. And here is an example of an inferencing tool, which is AI Bricks. Of course, it's now becoming a part of the CNCF. but it's an open source initiative which drove the idea of Gen AI inference infrastructure. And it's a very popular tool. I hope you are able to read about it once you leave the session. And similarly, there's LLMD. Again, it's based on a distributed infrastructure. It uses it uses Kubernetes, inference gateway, and VLLM together to build the distributed inference ecosystem, which of course has an aware routing, a disaggregated serving, and KV cache. But these are two popular inference tooling out there that are driving the cloud native plus AI native ecosystem together. And then how is Kubernetes driving inferencing? I mean, what has the Kubernetes ecosystem or the Kubernetes special interest groups done to ensure that it's easier to allocate your resources, it is easier to understand what kind of resources a particular infrastructure or a Kubernetes platform wants. And that is where we are live with Kubernetes 1.35, which went into GA recently, but the dynamic resource allocation, similar to like, say, a dynamic dynamic volume provisioning, which is in the storage part of things, helps you allocate your resources in the right way, helps you allocate your hardware accelerators. And it's already in GA with 1.34 and 1.35. So make sure you're able to try it out. The contributors, again, are from NVIDIA, Kevin being a good friend of mine. So let's talk tooling. People who are using platforms, let's talk tooling. Let's talk a little bit of platform engineering. And we'll start with my idea of platform engineering, or my idea of how platforms look like. This is an example of a 5-step platform that I have built. It's built on 5 simple steps on how you can start platform engineering, and then it has the sub-steps. Of course, you start with the developer experience. You need to ensure that the developers are getting the right portal or the right standardized tooling. And developers don't want to learn code. I'm not sure how many of you here are developers in the room, but you know that beyond development, you're doing everything else. You're not just writing code. You're asked to do integration testing. You're asked to do, you're asked to do chaos engineering, resilience engineering. You're asked to learn the whole CNCF landscape, which I myself use the microscope to zoom in and identify all the tooling. So developers want to go beyond learning the new tooling and infrastructure, and that is where the developer experience comes into play. And Backstage has been a very prominent open source tool, but you can see the options, and then you move on to the security, identifying the CVEs, mitigating them, your software supply chain assurance, putting the right policies in place with OPA or Kyverno. And then comes the foundation of your platform, which is your CI/CD, which is your infrastructure as code, your managing your APIs. And I mean, Argo has been one of the most popular tools driving the GitOps side of things. But again, you see Kong for the API management. You see Feature becoming a very popular feature flagging tool. And feature flags is a very important aspect. Again, your applications are dynamic. You need a particular feature. So that creates the foundation of your platform. And then comes resilience engineering, of course, managing your incidents through incident management, chaos engineering, your integration testing, your software reliability management. And lastly, it's your cloud cost management and the insights and the observability part, where perhaps you're using Datadog or Elasticsearch or OpenSearch right now, with the open source ecosystem becoming robust in the logging side of things, and then OpenTelemetry, of course, for the aspects of monitoring, logging, and tracing. So this is how I see the platform of today and how the platform engineering side of things are driven. But we'll talk about certain tooling which drives the AI native platform engineering. The first tool that I have taken is K8s GPT. I'm sure many of you know about it. It's a debugging tool. Once things go wrong in your system, or there's something wrong in your system, you need to go through the logs, and that's a hassle-full process. And K8s GPT acts as an LLM, basically powered by your CLI, and ensures that you are able to debug anything going wrong in your Kubernetes environment. And it's basically using Gen AI to analyze your cluster state, your cluster provisioning, and remediation suggestions, of course. The second tool is K-Agent. It acts as an agent built on a Kubernetes native framework. and it is a very popular tool to orchestrate different agents in your Kubernetes ecosystem. You can build, you can deploy, you can manage your AI agents in Kubernetes, and this is how the architecture looks like. This is the second tool, I believe, pretty vital for your platform foundation. The third tool is GitOps. I'm sure many of you who are utilizing containers or are aware of the OCI Artifactory are aware that on the OCI side of things, it's more about the Docker runtime. But GitOps has made it easier by packaging all your DevOps practices as an AI ML model. And this is a very popular tool today. A lot of my folks, even at Cloud Foundry, are utilizing this tool. So you can standardize how you package your AI ML workloads and then deploy them using GitOps. Kubeflow and Kserve. Kserve, of course, is on the production side of things. I will just talk about Kubeflow so that I'll allow Bharat to get some time in talking about tooling and platform engineering, how you deploy it. So Kubeflow, of course, while you are, developing or deploying your AI model in production, it goes through a developmental phase where again you are utilizing a lot of tools. You're hosting, GPUs. You're hosting your AI ML workloads on say AWS or Azure, and then you are using Kubernetes as the OS or the orchestrator. But there has to be a workflow between the interaction between the clouds and the Kubernetes operating system in itself. And that is where Kubeflow comes in. It acts as a workflow, and it helps you build your AI platforms on top of Kubeflow, which ensures that there's a simpler interaction, not just in your developmental phase, but also in your production phase, making tools extensible, modular, and scalable. So this is my idea of an AI-driven platform. I spoke about platform engineering, but these are some tools that are driving the AI-driven platform of today. You can start with an AI-driven developer portal. I have seen Nebius. It's an enterprise tool, but a very popular and a very secure one. Again, ChainGuard and SailPoint are doing a lot of things around AI security, which you can check out. QAI, I thought, is one of the upcoming tools or the growing tools that is built, that is not just allowing agentic Kubernetes, but it's also allowing agents, multiple agents run on a Kubernetes ecosystem or a cluster. There's GitLab, of course, driving AI for software delivery, harness, and then the tools that I spoke about. And eventually it's your AI SRE, which is helping you with the resiliency aspect of it. And KubeCost, Cast AI, which are very popular cost optimization tools driving the cloud cost management side of things. So this is what an MCP server looks like for a cloud native tool. You can see MCP servers basically act as USBs for different tooling, ensuring that you have a standardized approach. You are able to interact with each and every aspect of your tool. I've seen MCP servers for each and every cloud native tool out there. But that's what is simplifying tooling for you. It was pretty hard to use certain tooling in the cloud native ecosystem, but MCP servers have ensured that you're able to interact with different components of the tool. So these are some stats on the AI infrastructure explosion and how things have moved ahead. And hopefully we are going to see 75% of the cloud native engineers being AI ML engineers in the next couple of years. And perhaps if we have an AI summit in a couple of years, I'll come back to deliver that talk. But with this, I'll allow Bharat to take over and Bharat to talk about the AI product side of things and how you can build the platform engineering aspect using an AI workflow.
All right. Thanks, Prithvi. Thanks, Satyam. So yeah, that was a lot of information, right? I want to quickly go through this and then sum up so that we can move on to the next phase, right? The challenges that are primarily involved in coming up with the entire AI infrastructure workflow is that it can take weeks to properly set up, do things manually, which is again a real pain. Because to work with NVIDIA drivers, if any of you have done that, you'll know the pain. For us to set up everything from scratch is one of the biggest challenges right now, right? And so this eats into the development life cycle wherein you want to focus on your building the AI apps and not building the platform, but eventually you'll land on this, right? So yeah, before this, to sum up, what what we're trying to, like, why are we here? So what we're trying to say is the end user experience is something that a lot of AI models are focusing on. Every day we have a new model. Every day models are getting better and better in the things that they're doing, and then specialization is taking place. But what about the platform side of things? What about the things that are powering the back-end side of things, right? So the infrastructure of AI is what we want to talk about. And in that journey, we saw the challenges from the developer's perspective, from the platform engineering perspective, and then the whole new world of cloud native engineering. There's like too much information, too many things to catch up on, in this open source world. So the last bit that Prithvi talked about, the 5 steps in making a resilient, future-ready AI platform, is what one such open source project called Cordon focuses on. The difference is in the composable nature. So the approach taken to build this platform lies on how to make it composable. Why composable platform engineering is so important. So think about this end user workflow, right? You have your development team, you have your QA, you have your chaos engineering team, and you have your DevOps team. Each team requires a different set of requirements for the platform to come up. If you don't make it composable from a platform engineering perspective, then you'll sit there trying to deliver custom solutions for each team, which is just not very good optimal engineering. So making it composable, what that gives us is, for QA team, let's say they need a 10 node cluster. All you need to do is change the configuration. For development team, they need a quick test cluster of 4 nodes. You can do that. QA team, chaos engineering probably needs 4 node distributed across clouds so that we can test the real stress testing and all that. That could be easily configured as well. So the composable nature of the system becomes extremely important, right? So I'm not going to spend too much time on this because I want to show you in real time what these means. But I think this is already pretty much talked about. The common control plane being Kubernetes is really the key over here, right? Yeah, so I think this gives us a lot of information. So the approach that Cordant has taken is relying on the upstream open source projects and separating this whole platform engineering problem into essentially 3 parts. One is the cluster management, second is the state management, and third is the observability part. So observability part is pretty straightforward. No matter what kind of a platform you build, if you don't have eyes and ears, there's really not much we can do, right? So using open source tools such as Prometheus, Grafana, OpenCost, OpenTelemetry, and all these things bundled into a platform, right? Now comes the other 2 bits. So there's cluster management and there's state management. So it's essentially the 2 mirror images of platform engineering. While this talks about the day 0 things of stuff, this talks about day 2 things of stuff. So for cluster management, we are utilizing the upstream Kubernetes project called as Cluster API. If you guys have heard of CAPI, that is the standardized way to provision clusters, right? So when this was standardized and a structure was formed around it, all the other cloud providers too agreed that, right, this is the way to do it. And then, for example, if I take AWS, there's cluster API provider for AWS, and so on and so forth, for Azure, for GCP, for OpenStack, for bare metal, and so on, right? So we're using that. Now for state management, what I'm talking about here is that, let's say you do have your cluster, now what? Now we need to deploy applications, right? For the people to deploy applications, you need certain tooling in place. One example I can give you is about Ingress. So everybody uses Ingress. No matter what kind of application you build, you need networking in place. That could be handled by state management, right? In the interest of time, I'm going to skip ahead. Yeah. So in the service management aspect, we've built an open system where everything is handled via catalog, wherein we can basically install the services that we need in order to manage the platform that we want. I'm going to show you a live example, hopefully, and talk about that in depth, rather than through the slides. Just before that live demo, I want to focus on Cordant AI by explaining what infrastructure as a service platform is, right? So the technological stack that we want to build on is using infrastructure as a service. So what happens is the bottommost layer, we have the bare metal servers. So like I said, because CAPI is so extensible and works, plays nicely with all the platforms out there, we can either think about this being your AWS or this being your Azure or this being your actual bare metal private cloud. On top of this, we're going to install the operating system of your choice, right? Now, on top of that, we'll have the GPU provisioning. What happens in GPU provisioning is we'll end up using the infrastructures like NVIDIA or AMD. Of course, NVIDIA is the most popular one, but then some use cases we have seen wherein AMD is also requested for. Now, on top of this, so while this forms the infrastructure layer, right, now comes the software engineering or tooling layer. This is where the core of Cordon comes into picture, where utilizing the underlying infrastructure, we will deploy Kubernetes clusters on top. Now, finally, again, the example I'm going to show you in the live demo is of NVIDIA as well. So just talking about NVIDIA, let's say there are GPU operators to be installed, right? That sits on top. And so this is composable again. So as you can see, my point, like I'm trying to emphasize that each layer in this is like choose, option that we can choose and plug and play infrastructure. Now, with NVIDIA as an example again, I showed you this earlier, wherein each layer is building on top of one another, while the bottommost layer being the infrastructure layer and the topmost layer being the actual application layer. Now, we are focusing on the middle part here, which is where the Kubernetes clusters are basically organized, and then on top of the Kubernetes clusters, the services are deployed. So as you can see, the operating system, which contains a container runtime, and then the container management with the GPU as well, is part of this compute layer. So yeah, before I show that, two things we should know about Cordant, right? Everything is templating system. So the emphasis on infrastructure as code is something that's avoided here. So I'm sure you guys must have used, let's say, I don't know, Ansible, Terraform, Crossplane, all these tools, right? So all this comes into the category of infrastructure as code. So while they're really extensible and powerful, it does bring in the additional requirement of external tooling and the maintenance burden that you have to do. With that, some of the practical challenges are finding the right kind of people who are experts in those particular technologies, which is something that a lot of companies struggle with because, again, these are niche. That's something that Cordant avoids as well, again, because it literally just relies on Helm charts. So as long as you're aware of YAMLs and Helm charts and kubectl, that is all you need. So the day zero cluster templates is what you need. And as you can see, every cloud has a template that is predefined and pre-built, and you can choose the configuration that you want based on the templates that we have. And then the services exactly mirror them, wherein you can choose the services by the templates based on the kind of applications we need, right? So here's an example of cluster deployment. Actually, I'm going to skip this because I want to show it to you on the real thing as well, right? So yeah, Satyam, if you could just open the application. Okay, while he's opening that, let me talk about the open source components that was there in the previous slide. So in the container runtime, we use something called K0s. So if you guys have played around with Kind, K3s, K3D, and all these, right? So these are basically Kubernetes distributions, and K0s is yet another such Kubernetes distribution, right? So K0s is the underlying container runtime. On top of that, we are using the CAPI and all the cloud providers out there. Now, in conjunction to that, the state management is managed by SvelteOS. So SvelteOS is another open source project, which is used extensively. It was really nicely paired with Argo CD and similar stuff before, but now the GitOps is nicely integrated into this as well, right? Yeah. So this is what I want to show. If you just scroll up a little bit. So here's the definition of how your entire configuration for a AI-ready Kubernetes cluster looks like, right? So the first part of the YAML is defining the cluster spec, and the second part of the YAML is defining the service spec. And cluster spec, for this example, I've chosen Azure to do it. And as you can see, we're just choosing the template, and then we're specifying what flavor and image we need for control plane, and what flavor and image we need for worker. And the critical part over here is that for the worker nodes, we're choosing a VM that has a Tesla T4 NVIDIA GPU available. So this is, again, one of the examples of composability I'm talking about. If we want to swap out, then we can just swap this out with another flavor for a bigger GPU, let's say an H100 or an A100 or so on. And if you scroll down, this is where the services are mentioned. So you just need to mention the service, the NVIDIA GPU operator, and then the Istio services, cert manager, and kserve and knative that we mentioned earlier, right? And if you go to the other tab, yeah, and if you can just run the script. So the example that I've taken to showcase here is AI-based application which uses translation from one language to another. So I think we're running out of time, but essentially what I wanted to talk about was showing that the entire stack was built, like I would say about 15 to 20 minutes, starting from the provisioning of the Kubernetes cluster, where it goes to Azure, spawns the VMs and all the networking components and storage components and the GPUs, and then installing these services on top, which is the NVIDIA GPU operator and all the other things that I showed you, and then finally running this application on it, right? I don't think we'll hear because there's no mic connected there, but essentially I had offline AI models running, wherein it's translating a welcome message from English to Hindi. And the way the application is built is also that we can, yeah, I think the audio is being played right now, but yeah, basically we can swap out the AI models also that are being used to choose the models that we want. That's the thing I want to show. Can we go back to the PPT again? All right. So one limitation that I noticed and something that India is really working on is the need for India native AI work, right? For example, the voice that I wanted to show you is that we are lacking in India's specific AI models compared to the models that are there in the world, right? So this is something that we can take away from the session, the emphasis on India native models. So what's the future looking like? I think I'll leave you with this single slide, wherein we've already built the initial infrastructure Kubernetes layer, and we've built the AI GPU layer, and finally the future is looking into integrated MCPs, right? So wherein on top of all this, now my cluster and application should be able to talk to the various MCP servers and also be autonomous in that nature. So yeah, I think I'll leave with that. We can connect later for Q&A and talk more. Yeah, thank you so much for this opportunity. Thank you all.